This morning, I knocked myself in the head with the phone.
That actually took a while. I had to put more and more nickels into his handset until he got used to the weight, and then I just took them all out.
So the clip you just saw was taken from The Office. It's tangentially related to the topic I'm going to be presenting on. My name's Amit Singh. I'm going to be talking about Weber's Law today. So what Weber's Law is, it's talking about the actual change in physical stimulus versus the perceived change in physical stimulus. In the clip you just saw, basically how it relates to the prank is that the actual change in physical stimulus is that each day a nickel was being added into the phone. Now, there was no perceived change because the person, Dwight, didn't actually realize that the weight is changing. There was no perceived change. Now, what ends up happening is that when all of those nickels are removed, Dwight thinks the object weighs a lot more than it actually does in reality, and so he ends up knocking himself in the head with the phone. And so that's basically how Weber's Law plays into creating this extremely amusing situation. Now, weight perception is just one of the aspects of Weber's Law, but in general, what the law is stating is that the change in a stimulus that will be just noticeable is a constant ratio of the original stimulus. Now, just an example so you can understand this. If we have a weight of 105 grams, that can just be distinguished from that of 100 grams, our JND, or differential threshold, is 5 grams. Now, if the mass is then doubled, the differential threshold also doubles to 10 grams. So that the 210 gram mass can just be distinguished from that of the 200 gram mass. And 1,000 gram mass can be distinguished from 1,050 gram mass. Now, in this example, a weight seems to have increased by 5% for someone to be able to reliably detect the increase, which would make the Weber fraction 5 over 100 or 1 over 20 for detecting changes in the weight. Now, what Weber actually did is he assumed that all JNDs are subjectively equal and that there's a logarithmic relationship between the stimulus intensity and sensation. Since then, this has been disputed many times. People have just proposed that a power law would be a more general psychophysical principle than Fechner's logarithmic laws. You can see in the graph that I put here, but just still an ongoing topic of debate. Now, just a little about the history of Weber's Law. The law was originally postulated to describe researches on weightlifting by the German physiologist Ernst Heinrich Weber in 1834 and was later applied to the measurement of sensation by Weber's student Gustav Theodor Fechner, who went on to develop from the law the science of psychophysics. Now, other types of stimuli that Weber's law has been applied to, sound. At lower amplitudes it actually doesn't hold up, but at higher amplitudes or higher volume, it does hold up. For vision, they've noticed that the eye also senses logarithmically. If you look at this situation where we have, to the right, we basically have 4 boxes. And in the boxes below them, we have the number of dots in the boxes. So in the left set of boxes, you can see that there's 10 dots and 20 dots. And it's quite easy for me to distinguish. I could tell you, yep, the box below has a lot more dots than the box above. But for the right pair, you can see that it's much harder to tell. And this is because there's already 100 dots added in for both of them, and so that makes a lot more noise that you have to distinguish amongst, and so that makes it much harder. And so that's just a basic example to illustrate Weber's law in the visual sense. Now, there actually are applications outside of sensory stimuli. The distance effect. So psychological studies have shown that it becomes increasingly difficult to discriminate between two numbers as the difference between them decreases, also known as the distance effect. And this is actually used in explaining why consumers neglect to shop around to save a small percentage on a large purchase, but will shop around to save a large percentage on a small purchase. But if you compare the dollar amounts, it doesn't add up. For example, most consumers would go for a 50% discount on a $2 purchase, which only goes to $1, but they might not they won't shop around for a 1% discount on a $1,000 purchase, even though that adds up to $10, just because of the differences in percentages. And another example is public spending in politics. What we see is that election after election, voters demand more public goods to be effectively impressed, which basically just saying that people want more and more public spending. And so politicians will create different sort of signals that they're increasing spending each election cycle, even though they may not be doing that in actuality. just as a means to an end to collect more votes. And so, just going to conclude there. This is Weber's Law, and I hope you enjoyed the presentation.